Now, the last bit here is about multiple decision makers. So this is a situation that arises quite commonly. It's something that I've dealt with many, many times in management consulting engagements. So an organization wants to make some sort of decision about something. And so as the consultant, you've got to set up some kind of decision-making process, often one that has a consultative nature to it. So there's a whole lot of, they might often just people inside the organization, or I've done it for industry associations where there are members and the members want to have a say in the decision. And so what you're going to have to do is aggregate the input from those stakeholders. So if you have quantitative ratings or comparative judgment weightings and ratings, then you're going to be looking at some kind of averaging. Now, in some ways, the best is probably the median. So in this case, I've got 7 raters here with 7 ratings, and the median there is 6. But there's a kind of, there's a sort of psychological objection to this, because when you use the median, particularly if there's an odd number of people involved, you're going to be choosing the rating of one of the people. It might be more than one, but it could just be one of them. And so the others might get upset because it looks like you're just favoring one person or a very small number of people from the larger group that did the rating. So the median may not be acceptable for that reason. The median has the advantage, of course, that it's not really affected by outliers, and that's actually a good thing in this situation. But you need to be conscious of this this possible reaction to it. So the most common thing people probably do is they just use the arithmetic mean. There's another approach, and this is one we saw with the Olympic skateboarding scoring thing. This is a version of a trimmed mean. So what that means is that you chop off the highest and lowest ratings, typically, and then you calculate the arithmetic mean of what's left. That can have some advantages, but it still has the problem that there are going to be some people who may feel disenfranchised because their ratings have been left out, have not been taken into account. So you'd need to be careful about when you use that. If you have ratio level measurements, which you will get from comparative judgment, then the best practice is to use the geometric mean. And there's an Excel function for that. It only works for numbers that are greater than 0. If you've got a rating of 0 in your ratings, it will just throw up an error. So you need to be aware of that. Biggest problem really with the geometric mean is if you're doing it in this context where you've got to explain to people what you're doing, because then you've got to explain to them what a geometric mean is. If you want to know why a geometric mean is better than an arithmetic mean in this situation, I can give you a copy of a paper where that is proven to be the case, but it's just page after page of advanced mathematics, and I don't actually pretend to really understand it. I have done simulations of typical sets of ratings to see whether there's a big practical difference, and I don't think there is. So I wouldn't get too worked up about that unless you're doing something in a very high stakes situation where you don't think there'll be a problem about having to explain what a geometric mean is and so on. Or indeed, if you can get software to do all of this, but if some of you might end up wanting to write an app or something to do this sort of thing. In that case, you probably would want to use the geometric mean. I'll mention one other thing here. This all along here, we've been talking about the weighted additive model, or weighted sum model, it's sometimes called. There is a a better decision rule, which is called the weighted multiplicative model. You can Google it if you're interested. It has some advantages. Its main advantage is where you are not just using ratings in your MCDM, but you might say you're looking at purchasing cars for a fleet of cars, and you want to look at things like fuel efficiency and maintenance costs. You can incorporate them into the matrix. Now, Bianca. So what Bianca's asked there is about, what's practical for ratio level measurements. Look, I think it really depends on whether the situation requires you to explain what you're doing. And I don't think there's a very big difference in any case in most situations. But if I went and did a consulting job in an average sort of organization where I would do that, probably nearly everyone involved wouldn't have a clue what a geometric mean was. And if I was doing it in a way where, because sometimes, quite often when I've done this, it's all done in one day or one morning in a room with all the people there. And they sit around in groups and, you do everything, and it's all done on a projector, and you do the calculations and come up with the results. So everyone can see what you're doing. And if you're doing this in a spreadsheet and then you've got a geometric mean function there, it's pretty likely going to be someone in the room who puts their hands up and says, what the hell is a what's this geomean function thing you're using? And then you've got the problem of trying to explain it or explain why you're using it. So really, for most practical purposes like that, in those situations, I just use the arithmetic mean. As I say, they're usually, for the kinds of numbers that you're going to be using in ratings, there doesn't seem to be, much of a practical difference. Okay. Aggregating categorical measurements. All right. So this is the sort of thing that you use when you're doing the you're working out which alternatives to choose, to triaging your alternatives for an MCDM, or you're triaging the set of objectives or consequences or criteria that you're using. So one really good method in practice is what's called the nominal group technique. And we did a little exercise with this in the tutorials last week. So and I did explain it there, and people had no trouble doing it very well. So, but the basic idea is it's a kind of brainstorming technique. So if you're doing this in a room, and I've almost always only done it in a room where I have a bunch of people, and it can be a fairly large number of people sitting around. What you do is you typically, the standard way is you randomly put them into groups. And that's what nominal group means. Nominal means the group a person is in it's a group in name only, and just for that purpose on that day. They're not sitting in a group with people that they work closely with, or with people who have some common interest in relation to the decision. It's just a randomly assigned group, and they're typically sitting around a table. So the brainstorming bit is they start the process. They choose a person to be the rapporteur, the person who reports back, and then they spend some specified period of time, might be 5 or 10 minutes, individually, with no discussion, no talk, making a list of, I'll call them here items, whatever the thing is that you want to aggregate. So each person in the room makes their own little list. And then you get, the next stage is the facilitator or the rapporteur traditionally turns to the person on their left and says, what's the first item on your list? And that person tells them, and they write it on a whiteboard or a flip chart or a piece of paper. And that becomes the first item on the group's list. And then they go to the next person and say, what's the first thing on your list? And then that goes on the board as well, unless it's the same as the thing that the first person came up with, in which case they go to the second person, the second thing on that person's list, and so on. And you just keep going around the group doing that. And there's no discussion except to deal with cases where it's a bit unclear whether something that someone has come up with is the same as something that is already on the list. So sometimes there's a little bit of discussion about maybe amalgamating two things that are very similar or changing the wording a bit and so on. But the facilitator has to be pretty strict about limiting the discussion to that. And what happens, I mean, every time I've done this, it generally only takes about 2 or 3 passes around the group and you've got everything. You didn't just come up with stuff that's being repeated. So when that process is finished, then, and we didn't do this in the tutorial groups, but then you have what we call a plenary session. So then the person who's running the whole show at the front of the room turns to the first group and says, what's the first thing on your group list? And that goes up on the whiteboard or gets typed on the projector or whatever. And the process is then repeated in exactly the same way, but with groups rather than individuals. And so what you end up with is, and again, you know, it's usually 2 or maybe 3 passes around the room and you've got everything. So that's how you get a kind of aggregated list of suggestions or ideas from a room full of people. And you can easily do that with 100 people in a room, no problem. And if you're a management consultant, you actually get paid quite well to do that, given that it's not exactly rocket science. Then once you've got the short list, so I've got a whole lot of detail there about how to do that. But the next thing is, how do we, that's fine, but say we've got a list of 25 alternatives or 25 sets of consequences or whatever, and we only want 6 or 7. How do we narrow it down? And what you want to achieve generally is you want to rank the list and then choose the top, you know, 5 or 6 or 7 or whatever you want to use. So one technique that works very well in this situation is a pretty simple voting procedure. I mean, there's nothing, it's got a name, it's called border counting. And oddly enough, it's a pretty good voting system, but it's only used in 2 countries in the world. It's used in Nauru, for the island of Nauru, for something, for electing politicians, and it's used, I think, in Estonia for electing part of their legislative assembly, if I remember rightly. But this is how it works. I'll give you an example here. So this actually came from an exercise I did a few years ago where I had so this is before the idea of Cambry was born, and there had been a debate at ANU for probably 40 or 50 years about whether to build a swimming pool. And I must confess I knew nothing about this debate, but I was told that certainly in parts of the university, like over in the sciences, people were either in the academics, they're either in the pro-swimming pool camp or the anti-swimming pool camp. It turns out that our current Vice-Chancellor, Brian Schmidt, was in the pro-swimming pool camp. So when Cambry came along, a decision was made to build a swimming pool. But before that, it had been a controversy and various attempts had been made over the years. So I did this exercise with 32 students, and we did the nominal group thing. And what we were looking for were criteria. We were doing an MCDM as an exercise. So we were looking for criteria for the MCDM matrix, where the decision was about, there were 3 options in that case. There was build a swimming pool, build a stadium, or build nothing. I think they were the 3 options. So so we did the nominal group thing, and we came up with this list here of I think it was about 14 or something possible candidate criteria. And then we got them to vote. So what I'm showing you there is this is just the votes of 5 of these students. So the student I've called V1 here gave quick completion they ranked that 14, which is the lowest, and they ranked profitable as the first. Okay, so their first when they ranked these criteria at the top of the list was profitable, at the bottom of the list was quick completion, and what was number 2? Enhancing ANU's reputation. So each of the 32 students did their ranking, and then we just did a simple calculation, and the calculation here looks harder than it actually is. All the calculation does is it converts the 14 to 1 and the 1 to 14. So it's turning it from a ranking into a score. So the idea is that the highest rank thing, profitable here for the first student, that would get a score of 14, and the lowest rank, quick completion, would get a score of 1. So you do that by subtracting the ranking from the number of things you're ranking plus 1. And so what that gives you, that turns it into a table that looks like this. Okay, so you'll see now for the first student, can't remember why I changed those to C1 instead of V1, but it's the same student. You've now got 1 for quick completion, so that's the lowest possible score. And then for enhancing the reputation, you've got 13, which is the second highest score, and profitability, what happened? Profitability gets 14, which is the highest possible score. And then when you've done that, you just add them all up. So you add across the rows, and so you get these numbers here. And I've also did a column where I normalized these. So all I did was add all of these scores up and then divide each score by the total, and then rounded it and multiplied it by 100 and rounded it. And you don't have to do that, but sometimes it makes it easier to interpret. So that's all there is to it. That's what a border count is. It has fairly good properties. If you have enough people doing the ranking and enough things to rank, and everybody's conscientious and nobody sets up political factions and tries to game it and so on, you've got a pretty good chance of getting interval level measurement out of that. Okay, I actually tested it with these. These are actually quite good interval level measures. So that means that, you know, we can say that, say, flexible multi-use with 8, we can't say that's twice as preferred as likely to attract elite students at 4, but we can say that the difference between, I don't know, engage wider community at 6 and flexible multi-use at 8 is the same as the difference between flexible multi-use and useful for ANU community at 10. Now, almost always when I talk about border count in a course like this, with lots of students doing who've already done microeconomics and so on, as somebody raises Ken Arrow's impossibility theorem. I'm not going to explain that, but you can look it up if you're interested. But the general idea here is that no voting system is guaranteed to give you a perfect result. Okay, it won't give you a result that ideally represents everybody's preferences. And there's a whole quite substantial social science economic discipline called social choice theory, which studies all kinds of voting systems and so on and their properties. And border count is just one of many, many, many systems you can use. The reason I use it is that I don't use it in situations where the decision is highly contentious and people are going to try and rig the vote, or you know, and I don't use it in situations where I don't trust people to be pretty conscientious about their rankings. If I think there's going to be a whole lot of people just you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then it's probably not a great method. But I've used it a lot, works pretty well. People understand it, and it does the job. And that is all for today.